Okay, so jumping straight into question 1. We want to find the inverse for this function. Sorry, for x to be greater than or equals to positive 5. Why positive 5? Because this function is a parabola which shifted 5 units to the left. So 5 units left, the function is right here, going up. And it's just asking us to find the inverse of this. So the inverse from this to positive infinity. That would be not finding this part, just the right side. Then to do that is just finding the inverse of this. So y equals x minus 5 squared, switch the x and the y, and square root both sides to get rid of that squared. So the square root of x equals y minus 5. Add a 5 to both sides, you're left with y equals the square root of x plus 5. And this would be your solution. Well, this would be f inverse of x. Question 1. Question 2 is asking about, actually I'm not going to do question 2, question 3. So question 3 is asking for which values of x will f of x be invertible. Now let me give you a function. F of x equals 4 times x minus 7 squared plus 5. Now we just care about where the middle of the function is. This is a parabola because it's raised to the second power. Now this function, the 4 doesn't really do anything to the middle. The middle will stay wherever it's shifted, and this middle is shifted. Remember the parent function's here, so this middle is shifted 7 units to the right and 5 units up. So this point, it's located at 7, comma. I don't really care that it's shifted up or down. I just care about where the middle is located on the x-axis. So this function is invertible from 7 to positive infinity, or from negative infinity to 7. It could be invertible from here to the right or from here to the left, because either one of these halves will pass the horizontal line test. Sorry, that question I just did was actually question 4, not question 3. Question 4, it's something like if f of 7 equals 21, what is f inverse of 21? And of course the answer to that would be 7. The next question, question 5, it's asking us to find the range and domain of 3 raised to the x. Well, this is the parent function. 7 raised to the x, that is the parent function. 8 raised to the x, that is the parent function. The number here, that doesn't really matter. This is the parent function of an exponential function. Exponential function looks something like this, with a horizontal asymptote right on the x-axis. I'm asked to find the range and the domain of the inverse, f inverse of x. So I don't really have to find the inverse of this, whatever the problem may be. I don't have to find the inverse of this. I just have to find the range and domain of the of this. And this graph looks like this. This graph looks like this. This graph looks like this. Any graph raised to the x will look like this. So let's find the range and domain of this, which is our f of x. So the range of this function will be from 0 to positive infinity, and that domain will be from negative infinity to positive infinity. So that would be for f of x, but it's asking us to find the range and domain of the inverse. Well, the domain here will become the range there, and the range here will become the domain there. So the range will be from negative infinity to positive infinity, and the domain would be from 0 to positive infinity. Now this problem, I'm going to use this graph, and I'm going to use the given graph of f of x to find. This time, let's find f inverse of 7. So f inverse of 7 is going to be equals to something. To find this, I need the graph of the inverse. Now, there's another way to find it. If I know f of something equals something, these two come together, just like we did on the previous problem. F of 7 will be equal to something. F of that something will be equals to 7. Now, using this function belongs to my graph. So this is the output 7. This belongs to the y value, and whatever that 7 is, that will be my x value. So when y is 7, there's 7, y7. Here, when y is 7, my x is 5. So f of 5 would give me 7 for the function f, not for the inverse. But if the function f of 5 gives me 7, then f inverse of 7 will be 5. Now question 7 has several things that it's asking you. I can divide all of these things. Well, I can find all of these things, and you will notice that all of the questions are based on the inverse function. So they give me f of x. Let me find the inverse of a function that would look something like this. Say that my function f of x will be something like negative 7x plus 3 divided by 2. So this is the function of x. To find the inverse, this will become x equals, I'm already changing the x and the y, divided by 2. So I'll multiply both sides by 2. So 2x equals minus 7y plus 3. Subtract 3 from both sides. So 2x minus 3 equals minus 7y. And finally divide both sides by minus 7. So then y equals 2 over 7, well, negative, and x, and minus 3 over minus 7. These two will divide up to become positive. So y equals minus 2 over 7x plus 3 over 7. Now this is my f inverse of x. Once y is by itself, this is the inverse. Alright, so from here I can find pretty much everything this graph is asking me to find. The domain, well, the range in the domain, well, this is a line. It's a line, so you know the range and domain are the same. Infinity to positive infinity. Negative infinity to positive infinity. Range and domain. So the range and domain of the inverse will be the same, because the inverse is also a line. The x-intercept of this function. Well, to find the x-intercept, I can just let y be equals to 0. Well, and remember, this is the y value. So if I let y be 0, I would get 0 equals negative 2 over 7 x plus 3 over 7. Leaving y by itself, I would have to subtract 3 over 7 from both sides. That goes away, and I'll be left with minus 2 over 7x equals minus 3 over 7. Then I can just multiply both sides by 7. So the 7 goes away with that 7, the 7 goes away with that 7, and I'll be left with minus 2x equals minus 3. Then divide both sides by minus 2. That goes away, so x equals 3 halves. And that would be the x-intercept. that would be it. Although you do not have to do all of this, because technically the x-intercept of the inverse is the y-intercept of the original. So before I multiply this by 2, you will notice that the y-intercept is 3 over 2. But it's good to know that. So that was the second thing that was asking for the x-intercept. Constant rate of change. This will be the slope of the inverse. Well, in this case, the slope of my inverse would be that. That's the slope. This is the slope of the inverse. This is the y-intercept of the inverse. And it would be the x-intercept of the original. So the y-intercept of the inverse is the x-intercept of the original, and the x-intercept of the inverse is the y-intercept of the original. Alright, that would be the second thing. Rate of change, that's the slope, and the range of the inverse, well, again, range and domain are the same. They're both lines, so the inverse is also a line, so the range and domain will be the same. This range and domain is the same across everywhere for a line. So yeah, this is both the range and domain of f of x, and it's also the range and domain of f inverse of x. And also the range is equal to the domain. Now, I'm not going to do an example on number 10, because number 10 and the one that I just did was asking me to find the inverse of something just like this. Just like that, and I just did it. There's the inverse of that. So I'm not going to do 10. I am going to do 11. So 11. This is the one problem that we practiced before actually taking the quiz. So let's do it.
My mom had to get her tires changed.
All right. Okay, for this one, I have the table, and I'm going to find the equation of this function, the table of the inverse, and the graph of the inverse. So the table of this inverse, well, x and f inverse of x is going to be 1, 2, 5, 10, minus 2, minus 1, 0, 1. So that's the table. Now the graph. Okay, so to find the graphs, I can just plot these points. So the graph of the inverse, let me plot the graph of the inverse first. So the first point is located at 1 to the right and 2 down. 1 to the right and 2 down. That's the first point for the inverse. Second one is located 2 to the right and 1 down. So 2 to the right and 1 down. And its point is located 5 to the right and 0, so just 5 to the right, 3, 4, 5, and 0. Next one is located just 10 to the right and 1 up. 2, 4, 5, 7, 10, and 1 up. And this would be the equation of the inverse. Now the equation of the regular function is going to go minus 2 and up 1. So minus 2 and 1 up. The second one, it's minus 1 and up 2. So minus 1 and up 2. And it's going to be 0, 5. So 0 and then 5 up. 3, 4, 5. And then the next one is going to be 1 and 10 up. So 1 over and 10 up. 3, 5, 7, 10 up. So my function now looks like this. In this question, I do specify that this function is a quadratic function. So this is half of the parabola. Technically, the other half would be over here. So I want to find the equation of this function. Take into consideration that this is f of x. Although it's asking me to find f inverse of x. Well, but to find the equation of this, I just know you have to remember that the parent function goes through here. So this function goes 2 to the left and 1 up. That would be f of x is equals to x, and it goes 2 to the left. So that would be plus 2 squared, and it goes 1 up, so plus 1. So this is the equation of this function. I need to find the equation of the inverse. So that's pretty easy. I'm just going to make f of x into x equals y plus 2 squared plus 1. Subtract 1 to both sides, so you get x minus 1 equals y plus 2 squared, square root both sides, so I'll be left with y plus 2, sorry, this is y plus 2 equals the square root of x minus 1. And finally subtract 2 from both sides, so y equals the square root of x minus 1 minus 2. Now this result is the equation of your inverse, is the equation of this graph. So that would be the equation, that would be the graph, and that would be the table. Alright, for number 12, I really don't think I have to go over it, but I still did a problem similar to it. Okay, so to find the range, this is f of x, and I'm being asked to find the range and domain, not of this, but the range and domain of the inverse. Alright, well, I can find the range and domain of f of x first. That would be the easiest thing. Find the range and domain of f of x first. So range, up and down. First begin with the farthest down. This function goes to minus 3, that's the lowest it goes. And the highest it goes is to 5. So minus 3 to 5, that would be the range of this function. The domain, that would be left and right. You can see the farthest to the left, that would be minus 2. And farthest to the right, that would be plus 5. Sorry, bracket. It has brackets because the points are included. All of these are solid points on the graph are included. So this is the range in the domain of f of x. Well, the inverse is going to be these ones, but just switched. So the domain, I'm going to write it as a range here, minus 2 comma 5. And the range, I'm going to write it as a domain, minus 3 comma 5. And that's it. That's the range and domain of this. Right, for this one, I don't have to, well, here's the thing. For this one, it's very easy because it's the parent function. This is the parent function of the logarithmic function. I cannot tell you a hint on this one without technically telling you the whole answer. So I'm going to do one that's a little harder than this one. Okay, so here you have this function. Sorry, I made that point by accident. This is the vertical asymptote, and this is my function. Remember that the parent function, just like this function, which is the parent function, starts at 1. So my point of reference starts at 1. Now the point of reference of this function has shifted here. So this function, the equation of this function, it's of course a logarithmic function. The equation of this function, f of x, is going to be equals to log. Now, I'm not giving you a base. I told everyone to assume that it's going to be base 10. So log base 10 of x. And if you notice, it moves from here, it moves 3 units to the right. So that would be minus 3. Then you see from here, it doesn't move either up or down. It stays there. Again, how do I know this is the point of reference? Well, I know that's the point of reference because the point of reference, it's 1 unit away from the vertical asymptote. So 1 unit away from the vertical asymptote will be right there. Now this thing doesn't go up or down. It'll be plus 0. Well, I don't need to add that plus 0 because it's nothing. Now this is the function. So I found the equation of f of x. But of course it is asking me to find the equation of the inverse. So let's find the equation of the inverse. So the equation of the inverse, that would be x equals log base 10 of y minus 3. The log is by itself, so I have to do the opposite of logging. That would be the exponential. Everything will be 10, so log 10 of y minus 3. So then the log and the 10 cancel out, and I'll be left with 10 raised to the x equals y minus 3. Finally, just add 3 to both sides. So then y equals 10 raised to the x plus 3. And this would be the equation of your inverse. This is f inverse of x. So 10 raised to the x plus 3. That's your equation for the inverse. Now the thing is asking for an equation, for a graph, for a table. Now it's fine if for the graph you find, because it's easy to make the table, right? Just choose points here on the line. And I was to say choose easy ones. Like you can see this is a nice point here, which is at 4. Look for another easy one. They don't have to be perfect. If you find this one located at 8, then maybe this one located at 15. That's just a few points. If you just want to approximate, maybe this one, which seems to be like at 0.5, that's like what, 3.5 at 10. So yeah, and you can make that I mean, you would have to, of course, do the table for f of x, because this is f of x, and then whatever you get, again, just flip them over here, and that's it. That's the whole test. Oh, there's this question. No, question 14. It's the last one. The last one. But this question is pretty much very similar to this one question. Here with the half parabola, you can find the equation of this function. I mean, actually finding the equation of this function would be nice. You already know, look, we found the equation of a function that looks just like this, where they just give you half of the parabola. This is half of the parabola, and we found the equation, we found the inverse, we found the table. We know where the point of reference is. That's already a few things you guys can find. So you can give me the point of reference of this function, you can give me the point of reference of the inverse function. You can also graph the graph of the inverse. One thing to always know, of course, is that the graph of the inverse is a reflection across this line. So you just reflect across, so this goes by 1.5, half and half. That one there, that point is always there, and the inverse would just be that. And that's it. Okay? That's all the questions.